if you divided distance by time, you would get speed. And if you divided displacement by time, you would get velocity. Let me repeat that. Speed is equal to distance divided by time, and velocity is equal to displacement divided by time. All right, so how much distance is a moving object covering in a certain amount of time is your speed, and how much displacement is an object covering in a certain amount of time is your velocity. Since distance is a scalar quantity, we divide it by time and we get speed, which is also a scalar quantity. And since displacement is a vector quantity, we divide it by time and we get velocity, which is a vector quantity. So just to reassure, we're writing scalars on the left side and vectors on the right side, okay? So it's easier to remember these things. Okay, now talking about the unit. The unit of distance is meters divided by the unit of time is seconds. So the SI unit for speed is meters per second, okay? And the unit for displacement is also meter because it's a length, and the standard unit for time is seconds. So the SI unit for velocity is also meters per second. Here. Now, if you have to write this in words, like if you have to write a definition, whenever you see something being divided by time, you can say rate of change of the thing that it's dividing, which is distance. So whenever something's being divided by time, you can write the definition by using the word rate. Rate of change of distance, okay? On the other side, displacement is being divided by time. So give it a try. What do you think will it be in words? Rate of change of displacement, okay? So let's copy that. Rate of change of displacement. All right, so that was it for speed and velocity. Let's do a little question now. Okay. Question. Let's say a car is moving at a speed of 350 meters per second for 2 hours for 2.5 hours, okay? So a car is moving at a speed of 350 meters per second for 2.5 hours. How much distance has the car covered by the end of 2.5 hours? So distance covered. Distance covered. Whenever you are given a question, it's a really good practice to dissect the question and make the information more clear. Like you can highlight it, make boxes around it, any way that it highlights the information, it's going to make everything easier for you. So you're given speed. I'm going to highlight speed. I'm going to write a little speed there, and it's moving for 2.5 hours. So my t, little t here, time, and what I want to know is the distance. Now we have the speed and time, and I want to know the distance. Can you think of a formula that connects these three things? We just learned it. And the formula is speed equals distance divided by time. I have the speed and I have the time and I want to figure out the distance. So I have to rearrange this equation, isolate distance such that distance is on one side of the equation and everything else is on the other side of the equation. If time is being divided here and I want to take it to the other side, I will multiply it with the speed, okay? So your distance is equal to speed into time equals speed into time here. Now, speed is 350 meters per second. I'll plug in the values that were given to me. 350, and time is 2.5 hours. There's a little bit of work that needs to be done here. You see the unit of speed is meters per second, but time is given in hours. That's not going to propagate that well. So what you need to do is convert your time into seconds, which is the SI unit for time, and I'll write down the conversion factor on the side. So if you're converting from hours to minutes to seconds, let's see how that works. 1 hour has how many minutes? 60 minutes, right? So if you want to go from hours to minutes, you multiply by 60. And a minute has how many seconds? 60 seconds. So when you go from minutes to seconds, you multiply by 60, okay? But if you're going straight from hours to seconds, you multiply by 60 twice. So 60 into 60 is 3,600. So when you go from hours to seconds, you multiply by 3,600. Now, if you go back, like if you were to reverse this, if you're going from seconds to minutes, you divide by 60. And if you're going from minutes to hours, again, you divide by 60. And if you're going from seconds to hours, you divide by 3,600. Now, you might ask, how do I remember whether to multiply or divide? The easiest way is to think about these operations. When you multiply something, the number gets bigger, right? And when you divide something, it gets smaller. We know that an hour has a lot of seconds, right? So 1 hour has a lot of seconds, right? 3,600 seconds. So when you multiply, 1 becomes 3,600. So multiply makes the number bigger. So an hour has a lot of seconds, so you multiply because you want to make the number bigger. But 1 second does not have even a single hour. 1 second has a fraction and fraction, like a smaller fraction of an hour, right? So you divide by 3,600 when you're going from seconds to hours. Okay, so your time was 2.5 hours, and from hours to go from hours to seconds, you multiply it by 3,600. So 2.5 into 3,600. Now grab your calculators and let's see what we get. 350 into 2.5 into 3,600. Oops, that's a lot of distance. Okay, so we're getting, wow. So we're getting 315.1234 meters. Okay? Now, if you were to convert that to kilometers, remember that 1 kilometer has 1,000 meters. So if you're going from 1 meter, or hold on, kilo is used to represent 1,000. So if you want to write in kilometers, you can take these 3 zeros, which are representing 1,000. That would be 3150, and instead of these 3 zeros, you can write K for kilo meters. That's a lot of distance, probably because we took the speed to be that huge, and then we took the time for which the car was traveling to be 2.5 hours, so definitely covered that much of distance. I'm not sure if that's practical, but here we are. Okay, so we learned about one more thing here, which is the prefix. We call this kilo prefix. A kilo represents 1,000, and if it's for meters, 1 kilometer is 1,000 meters. So to write that number down in an easier way, which is to make it smaller, we could just say 3150 kilometers. Okay, these three zeros are replaced by the prefix kilo. Okay.